This is Anthony Precella. Today we're going to be continuing to work on the review sheet that we started the last time. This is a review for my first test in a face-to-face college algebra class. We've done problems 1 through 9 the last time, so we're going to be picking up with problem number 10. Solve this equation using the quadratic formula. So let's get to it. So let me write it down. 3x squared equals negative 12x minus 2. If we're using the quadratic formula, you gotta have that equation written in standard form. Ax squared plus bx plus c equals 0. And I always prefer the x squared term to be positive. So I'm not going to move the 3x squared over to the right. I'm going to move the 12x and the 2 to the left. Why? I want that 3 to stay positive. So adding 12x and adding 2, we have 3x squared plus 12x plus 2 equals 0. So A is 3, B is 12, C is 2, and I'm just going to plug into the quadratic formula. Let me write it down. Negative B plus minus the square root of B squared minus 4AC all over 2A. You're plugging into this quadratic formula. I always suggested don't show too many steps. Showing steps is good, but don't show too many because you're going to bog yourself down. To get started, negative b. I'm replacing the b with the 12. So we have the blue negative and 12. Plus minus the square root of b squared. Let's see, that would be 12 squared. That's something I can do in my head. 12 times 12, or punch into a calculator, 12 times 12, that's 144. Minus 4 times a times c. A is 3, C is 2. So it's negative b plus minus square root of b squared, that's the 144, minus 4 times a times c, all over 2 times a. The 2 times a I always do in my head. 2 times 3, 6. Now the next thing I would do is punch in the stuff that's under the square root symbol. Let's simplify that square root. I'm going to use my cell phone calculator just because it shows under this better. Okay, so punching in what's under the square root. 144 minus 4 times 3 times 2. That's 12 times 2, 24. So we have 144 minus 24, 120. We have square root of 120. So all of this is the square root of 120. Is that orange showing? Not much. Well, let's simplify that square root of 120. I'm pretty sure it's going to be simplified because there's not a single answer choice that has a 120 under the square root symbol. Well, odds are 3 to 1 that there's going to be a 30 under the square root. So does 30 divide evenly into 120? Let's see, 30 times what is 120? Is it 4? So I'm simplifying that square root of 120. Wow, that stuff we did on day 1. Okay? This is the fall of 2019 as I'm doing this. So there in August, on day 1, we were simplifying things like square root of 120. So the square root of 4 is 2, square root 30. So I've simplified the square root symbol. Now I'm going to write it all with one color, replacing that square root, all that stuff I've circled, with the 2 square root of 30. So here it is, written just as one big fraction. Negative 12 plus or minus 2 square root of 30 all over 6. Okay. That's not listed as an answer choice. We're not finished. Well, we can reduce. Simplest way to reduce this, I think, is to look at the 3 numbers that aren't under the square root. The negative 12, the 2, the 6. What number divides evenly into all 3 of those? 12, 2, and 6, a 2. So I'm just going to divide each one of these numbers here by 2. And here's what we'll have. Negative 6 over 2 is a negative 6. The 2 over 2 is a 1, so I'll just write square root of 30. 6 over 2 is 3. Negative 6 plus minus square root of 30 all over 3. So let's see, which one is that? Look closely. B and C look an awful lot alike, don't they? So it's going to be C, isn't it? Write your answer in the blank and move on. By the way, you write only one letter in the blank. Okay? If you write 2 letters, I'll choose the wrong letter and mark it wrong, okay? I'm grading this. If you do this, that's fine. I'm grading this, okay? If you were to do this, that's, that. Tell me though, it's one of those answers, you choose which one you want to choose. I'm going to choose this one and mark it wrong. But I'm not going to do that. Only one letter. Okay? So I'm just going to guess at random. You have a 25% chance of guessing unless you write 2 different letters. If you write 2 different letters, then there you have a 100% chance of getting it wrong. Okay? So let's do another quadratic formula. Number 11. Y'all caught up with me? Any questions? So number 11. X squared plus 4x plus 40 equals 0. Oh, wow. That one's already written in standard form, isn't it? We don't need to move anything around. All we need to do is write out A equals, B equals, and C equals. Don't forget that A is 1. Sometimes students, oh, what did they write for A? Well, you're assuming the number 1 is there in front. So A is 1, B is 4, C, the constant, is 40. I'll write out the formula and plug in. Negative B, this is the quadratic formula, plus or minus the square root of B squared minus 4AC all over 2A. Y'all are taking your test 1 week from today, so hopefully 1 week from today you'll have that formula memorized at least for a few minutes to write it down on your test paper when you get it. Okay? So negative B plus minus the square root of b squared. That b squared I do in my head up to this point. The 4 squared, that's 16, minus 4 times a times c. A is a 1, c is a 40. 40? Oh, wow, this number's going to get sort of large. All over 2 times a. I'll do that one in my head. 2 times a, 2 times 1, that's just a 2. Okay. And now, let's simplify under that square root. So I'm simplifying all of this. You do it by hand or punch into your calculator. Again, I'm using my cell phone calculator just because it shows easily under here, or it shows better. We have 16 minus 4 times 1 times 40. 16 minus 160 is a negative 144. So this square root, we have a negative 144. And can we simplify that? Well, yeah. What can we do to simplify it? 12. Anything else? 12i. You're taking the square root of a negative, so 12i. So I'm going to replace all of that square root with a 12i, and I'm going to go ahead and write it all in one color. Negative 4 plus minus 12i all over 2. Well, either do the division like we did a while ago, or if you just want to separate it, you're going to get the same answer either way. I'm just going to do the division. I'm going to divide these 3 numbers by 2, so I'd have a negative 2 here, a 6i there, and then 2 over 2 is just a 1, so no longer a fraction, just negative 2 plus or minus 6i. And watch out when you look at those answer choices. I was about to say A and B are the same. No, they're not. B is a positive 2. We want a negative. The answer choice is A. Any questions there? Just working through this review sheet. Next, we're going to continue solving equations. Problem number 12. So, heads up, it doesn't say on it if solve using the quadratic formula. So for 12 through 16, you shouldn't need to use the quadratic formula, okay? You shouldn't have to use it, okay? If it tells you use the quadratic formula, that means it's not going to factor. So you don't need to draw your parentheses and try to factor this one, okay? Like number 11. Same thing for number 10. Number 12. Let me write that one down. 1 over x plus 2 over 3x equals 4. Well, if we're going to solve an equation that has a fraction in it, the best strategy is to get rid of that fraction. So we need to multiply through by something that would cancel out or cross cancel with these denominators. Now for this one, to cross cancel this first one, just multiplying by x would do it, but that wouldn't completely cancel out this one here. So I'm going to multiply straight through by 3x. Multiplying by 3x. Even the 4 has to be multiplied by 3x. And if you want to, I'm going to write it as over 1, just so that you can tell the cross-canceling better. Oh wow, this one's going to work out pretty nicely, isn't it? The red x and the black x cancel, leaving just a 1 times 3, or 3. Then plus, what are we going to have here? 3x's cancel, leaving us just a 2 equals 4 times 3x is a 12x. Oh, this one's not that bad, is it? Once you have it written like that, you can add the 3 and the 2 to get a 5. And this is just a linear equation. What do I mean by that? There's no x squared in it. So just isolate the x. What would I need to do to get that x by itself? Divide both sides by 12. That's right. So dividing by 12. 5 over 12. Okay, let me see. Oh. Answer C. Okay. Sometimes students ask, will these be the exact same problems on the test? No. Different numbers, just like your homework and my homework are different. Okay? Different numbers. But they'll work out similarly. Okay? Ready for number 13? Problem 13. Let's see if we need to do let's see if it needs to be adjusted. Okay, that's about as good as it's going to be. Okay, so problem number 13 says solve this equation. And here it is, 1 minus 5 over x minus 36 over x squared equals 0. Well, we need to get rid of the fractions. So we have an x and an x squared. What could I multiply straight through by that'll cancel out both of those denominators? X squared. So I'm going to multiply straight through by x squared. Not sure why I did those first. Theoretically, even the 0 gets multiplied by x squared. I'm going to write that x squared as over 1 right here, just so you can see the cross canceling. Let's see, what would we have? Just a 1x squared, so x squared, minus this purple x in the bottom. It might not look purple to you, but it will on the screen. Cancels with one of these x's right here. So I'm just going to mark out that square. So we have 5x. And then a minus. That's this minus. The x squares cancel, leaving a 36 equals 0. Oh, I bet you that there's going to be some 9s and 4s somewhere along the way. Why am I thinking that? All the answer choices have either positive or negative 9 and positive or negative 4. So let's see. This thing will factor. Okay, how do I know that? Well, it doesn't say use the quadratic formula, and it is a quadratic equation, unlike the one we just did, number 12, which was a linear equation. This one's quadratic. So draw your two sets of parentheses. And there's quite a few pairs of numbers that multiply together to give 36. 1 times 36, 2 times 18, 3 times 12, 4 times 9, 6 times 6. The only pair that I'm going to even consider are the 4 and 9. So I'll put an X and an X, a 4 and a 9. We need that 4 and 9 to multiply together to give a negative 36. So what's that old saying I say over and over? The second sign is minus, then 1 plus and 1 minus. How should I arrange the plus and the minus in order to get a negative 5x?
Minus and a plus.
Okay, I'm thinking
Or plus and minus.
plus on the 4 and then minus. It depends on which one you write first, 9 or 4, but the minus goes in front of the 9. Because positive 4 minus 9 would give you the negative 5. At the same time, positive 4 times negative 9 is the negative 36. So I think I factored these correctly. Set each one of these to 0. And we get x equals negative 4. And x equals positive 9, and look closely. Oh wow. Okay, you need the one that has a negative 4 and a positive 9. That is A, correct? Answer choice A. Any questions there? Continue on. Problem number 14. Write that one down. It's problem 14. Negative 5x squared minus 6 all over x minus 4 equals negative 15x over x minus 4 plus 6. Well, what are we going to multiply straight through by to cancel out that x minus 4? Well, x minus 4. Okay? I'll multiply straight through by x minus 4. And here, we'll cancel. But it's tricky. Make sure you multiply that 6 by x minus 4 also. Let me move this up some. So let me write down what we have after all that messy canceling. But I'm multiplying by x minus 4 because that will cross cancel here and here. So we have a negative 5x squared minus 6 equals a negative 15x, and that's going to be a plus 6x and a minus 24. We had a homework problem on my lab that was just like this, with different numbers. And I remember it even had a negative right here, so I moved everything over to the right, and that's what I'm going to do here. It's an x, there's an x squared in it, so it's a quadratic equation. So factor or use the quadratic formula. I'm going to factor it. Regardless of how you go about it, you've got to get that 0. So on one side, I always like the x squared positive, so I'm going to do this. I'm adding the 5x squared and I'm adding the 6. I'm getting the 0 on the left. And if I move those over, I'd have a positive 5x squared adding the x's, negative 15x plus 6x, negative 9x, and then I'm adding the 6. Negative 24 plus 6, negative 18. So, y'all see that how I did that? Any questions on that manipulation there? As we were doing these in class the first time, I said this is a messy manipulation, and it's still kind of messy. Now see how I moved that stuff around? I rewrote everything to get it down to this. It's a quadratic equation. I'm going to factor numbers that multiply together to give 5. Numbers that multiply together to give 18. 118, 29, 36. And we don't really have any choices for the 5. It's going to have to be x and 5x. Okay? But which pair of numbers should we use for the 18? Well, why don't we look at the answer choices? We may as well take advantage of the fact that this is a multiple choice test, because, you know, there's that big disadvantage that you have to live with. And what's the disadvantage? Well, right or wrong. So I'm looking at the answers. Do I see 1s and 18s, 2s and 9s, or 3s and 6s? Well, I see 3s and 6s. Okay, I don't see any 18s there, or 2s or 9s. So I'm going to try to get this to factor with the 1 and 5 and the 3 and 9. So let's see. I have 0 equals, I'll draw my 2 sets of parentheses. Let me move this up so y'all can see it better. 1x times 5x. And I'm going to try it with the 3 and 6. Since the second sign was negative here, we need a positive and a negative. How can I make this work out? By that I mean make it give us a negative 9x. I have a 15x and a 6x if I want a negative 9x. The bigger number here needs to have that sign, so negative. And then the 6 is positive. So 3's negative. 6 positive. Did I factor that correctly? We have 5x squared, then a plus 6x and a minus 15x. That's given the minus 9x. And then negative 3 times positive 6 is negative 18. So yeah, I factored it right. Now set each one of these factors to 0. And we get x equals 3. And to isolate this x, you got to move the 6 over and divide by 5. So we have positive 3 and a negative 6 over 5. I was about to say A, but no, it isn't. It's not A, it is, which one? Oh, y'all can't see the answer choices. Sorry about that. Is it D? Yeah, I'm thinking it is D. Any questions there? Okay. Just auto-focusing there. We ready for the next one? This was one of the ones I thought was the most messy on here. Okay. Let's see. Oh, number 15. It looks like a hard one. It has a radical in it. Actually, it's not that bad. Number 15. We have the cube root of 4x minus 7 plus 5 equals 3. Let's see. What are we going to do there? Well, to solve a radical equation, you've got to isolate. If there's just one radical term, isolate that one radical term. If there's two radicals, you got to put one on each side. But here there's just one, so there's really only one correct first step on this, and that's to move the 5. If you don't move that 5 over and get that radical by itself, whatever else you're doing is wrong. Okay? So subtracting the 5, 3 minus 5 is negative 2. And now that I have the radical isolated, let's cancel out that radical. What exponent would cancel out a cube root?
3.
Yeah. So I'm going to cube both sides. The cube and the cube root will cancel out, leaving just 4x minus 7 under the, leave them on the left, 4x minus 7. No, don't say negative 6. Negative 2 times negative 2 times negative 2 is?
Negative 8.
Negative 8. So let's see. Isolate the x now. We have a linear equation. There's no x squared in it. So all we have to do is isolate the x. I think I was pretty kind to y'all on these. So add the 7. So we have 4x equals, is that a negative 1? Negative 8 plus 7, negative 1. Then divide by 4. So a negative 1 over 4 looks like our answer here. That is B. Okay. Oops. There. Answer choice B. Any questions there? Just working through this review sheet. Number 16 is, let's see, another radical equation. At first glance you might not think it is. You don't see the little root symbol, but sure it's there. 3 minus 5x raised to the 1/3 power minus 7 plus 7x raised to the 1/3 power equals 0. Well, oh, let me look this up. What we have to remember is what these fractional exponents mean. We said a 1 over n power is just another way of writing an nth root. So those 1/3 exponents are just cube root symbols. If it had been a 1/2 exponent, it would be a square root. A 1/4 exponent, a 4th root. So I'm going to write it with the red cube root symbols. And then I'll go through basically the same strategy that I used on the other one. Okay. Okay. There's two radicals here, so isolate it. I think I'm going to move this one over here. And then I think it's going to fall out really nicely. Okay, put one cube root on each side. So cube root of 3 minus 5x equals cube root of 7 plus 7x. What cancels out a cube root? Well, same thing that did a while ago, a cube. So the cube root symbols are just gone. I'm just writing what was under those. 3 minus 5x equals 7 plus 7x. This is a linear equation, so just isolate the x's. How do I want to isolate these? There's no way I'm going to avoid having a minus somewhere along the way. I guess I'll do this. I'm going to move the 5x over there. I'm going to move this 7 over there. So I'm subtracting 7 from both sides. And I'm adding 5x. 7x plus 5x, that's going to be a 12x. Still have to do one more thing to get that x by itself. Divide by 12. Don't say -3. It's going to be a fraction, isn't it? Smaller numbers on top, so it's a fraction. If it had been 12 over 4, it'd be 3. 4 over 12, well, we have a negative 1/3. Negative 1/3. Right there, D. No, not D, C. Okay. Any questions on that? I used to make a lot of just short videos, but it's such a hassle. It's as much work to upload a 1-hour video as it is a 10-minute video. That's why, okay, just let it record as long as I'm going. Any questions? Stop using my retro paper. Now, again, reminded of that student so many years ago that told me his teacher was such an idiot because he told him to study the instructions and stuff. And I was like, wait, that's a good idea. So now I have these students out there talking about me that way, I'm sure. That idiot, he tells us we're supposed to study the instructions on the review sheet. Well, yeah. Here's how the instructions are going to appear on your test. It's going to say for like 17, solve the inequality. And then it talks about writing your answer in interval notation, and we'll discuss all of that in a moment. But the thing is, it doesn't tell you, like over here, number 11, there can be no doubt. Use the quadratic formula. Here, 17, 18, 19, 20, 21, 22, all of those we're going to be doing one thing, but it doesn't say there. You have to know the name or what method to use on those. What do we do when we're solving something that has a less than or a greater than? What was the name of the method? 2 words. One starts with C. Cut points. Yes, cut points. Cut point method is how we solve inequalities. The instructions don't say use a cut point method. You've got to know that. Okay? So number 17, x squared plus 6x minus 7 greater than or equal to 0. So number 17. Well, we're ultimately going to draw a number line, plot numbers on the number line with open or closed circles, and then test intervals. Okay, the shaded true intervals are the ones that'll be the solutions. You start off by finding the solution cut points. So those statements that have the less than and greater thans, where the instructions talk about solve the inequality, that's when you do the cut points. If there's no fractions, like 17 and 18, there's no denominator cut point. Like number 19, there's going to be a denominator cut point. How do I know that? Well, there's a denominator. Okay? So you'll have a little sequence of steps like this that hopefully at this point you're familiar with. Find those solution cut points. Put an equals and solve. Use either an open or closed circle depending on the symbol. So let's see. I'm solving x squared plus 6x minus 7 equals 0. Well, that's a quadratic equation, and I can factor that without too much trouble. X and x, not a lot of numbers, multiply together to give 7, 1 and 7. And we want a positive 6, but we want it to multiply to give a negative. So second sign is minus, so 1 plus, 1 minus. How should I arrange those signs?
The 1 should be negative.
1 negative and the 7 positive. So set each one of these to 0. I'm getting a positive 1. And a negative 7. Those are the solution cut points. You look at this symbol to decide between open and closed circles. What are we going to use?
That's going to be closed.
Closed. We have a little sequence of steps that you just follow. It'll give you the answers. Next, you find denominator cut points, but there aren't any denominator cut points. So now we're going to draw the number line, label the cut points, and test the interval. So drawing the number line. Be sure you label those cut points in numerical order. Don't put the 1 here and the negative 7 there, or you're going to mess up. Negative 7 should be to the left of the positive 1. And now we're going to test each interval theoretically. I'm only going to test 1. If 0 is not a cut point, that's usually the one I use to test. So where does 0 lie? Is it between two negatives? Between a negative and a positive? Or between a positive, or between two positives?
Negative and a positive.
Yeah, 0 is always between a negative and a positive. So I'm testing 0 by plugging it into the original problem. If I get a true statement, I'll shade the interval. If I get a false statement, I'll cross it out. So plugging in a 0, I'd have 0 squared plus 6 times 0 is 0 minus 7 is greater than or equal to 0. So we'd have, 0, that's just 0 plus 0 minus 7, that's a negative 7 is greater than or equal to 0. It's sure not equal. Is it greater?
No.
No, this is a false statement, isn't it? So true and true. Pearson, my lab, you would type in the interval notation for the true intervals. Always use parentheses at infinities. Use square brackets for closed circles. We don't have any open circles, but if we did, we'd be using parentheses for open. And you type that in. But let's read through the rest of these instructions. when the solution is written in interval notation, what is the first interval in the solution? Well, if someone asks you what's the first interval here, I don't think we need to define what we mean by first. Most people know what I mean what first means. This one. This is the one that should be listed there, is it? Yeah. Okay. Negative infinity. Oh, no it isn't. I was about to say the answer is B, but no it isn't. It is C. Okay? It's only asking for the first interval for no real reason other than just to get all the answers on one line. Okay? Oh, they want all the answers on, just to try to use as little paper as possible. This test software I'm using here is trying to use as little paper as possible. That's why it only puts the first one there. If it wrote union blah blah blah, then it would wind up taking up more room there. Okay. Are we ready to do another one? This is that cut point method stuff. And you might think, well, it never said cut point. No, it didn't. But you sort of gotta know. How do you know? Well, you study those instructions. It says solve an inequality, or if there's just a less than or a greater than symbol there. And that's when you're going through doing the little cut points. Problem 18. Are we ready for that one? Are there any questions? X squared plus 7x. Ooh. Green's going dead. X squared plus 7x is less than or equal to negative 12. There's no solution denominator cut points here, just solution. I'll put an equal sign. And I think when I put that equal sign, I'm going to go ahead and move the 12 over. X squared plus 7x plus 12 equals 0. Well, there's another one that factors pretty painlessly. Hey, wait. Well, number 17, I didn't put this. Is it C? See, x squared plus 7x. Now doing number 18. Let's see. How is this going to factor? X and x. Second sign is plus, so 2 of the first. So plus plus. 1 times 12, 2 times 6, 3 times 4. What are y'all thinking it's going to be?
3 and 4.
3 and 4? Yeah. This one factors not bad at all. Set each one of these factors to 0. And we get negative 3 once we've isolated the x. And negative 4. Look up at the symbol to decide open or closed. And it's going to be closed. Why? There's an equal sign on it. Draw your number line. And label those cut points. Make sure you put them in numerical order. Oh, these are trickier to put in numerical order because they're both negative. Negative 4 and negative 3. Which one's going to be the one furthest to the left?
Negative 4.
Negative 4. If you put negative 3 right here and negative 4 there, you're going to mess up. No, if you put negative 3 here and negative 4, yeah, I said that right. Closed circle, closed circle. I'm going to go ahead and test the number 0. Where does 0 lie? Well, it doesn't lie between two negatives. 0 always lies between a negative and a positive. That means it has to be over here on the right. So this is the interval I'm testing. Sometimes students might wonder, why does he seem to think that's important? where 0 lies. I've got to know whether to mark that interval true or false. So 0 is over here, so I'm testing this interval on the right. And let's see, when I plug a 0 in here, I have 0 squared, that's 0. 7 times 0 is 0. Is less than or equal to negative 12. Well, it sure doesn't equal it. 0 is less than negative 12. Is that true or false?
False.
That's false. 0 is bigger than negative 12. You'd rather have $0 in your account than negative 12. I know it's harder and harder to get to be overdrawn nowadays, but it still happens. People still write paper checks occasionally. Like that. So false, true, false. And when you were doing your homework, you would type this in. Bracket -4, comma, -3, bracket. And that's the only interval. So when it talks about what is the first interval? Well, they tell you the first interval is the one furthest to the left, or if there's only one interval, then that's the first one. In the goal, they're trying to just write their answers spread out like this, just A, B, C, D in one line. Okay? There's no real deep reason why it's asking for the first one. Okay? Any questions there? Let's do one more and then call it quits for the day. Let me see. Problem number 19. I wanted to do one cut point where there's the denominator cut points. We have to go all the way through on problem number 19. By that I mean we have solution cut points and denominator cut points. X plus 21 over x plus 2 is less than 5. Are y'all caught up with me? Are there any questions? Find my solution cut points by putting the equals. I'm going to go ahead and write that as 5 over 1, because what am I going to do to solve this type of equation? When a fraction equals fraction. Yeah, I'm going to cross multiply. So I'd have a 5x plus 10 equals x plus 21. It's just a linear equation, no factoring here, so they do this. I'll subtract x and subtract 10. 5x minus 1x is 4x. 21 minus 10 is 11. Divide by 4. So here we have a cut point that's a fraction. Look up at the symbol to decide between open and closed circles. It is open. There's not an equal sign on it. So open circle at 11 over 4. Now here there's a denominator. So we need to find our denominator cut point. To find the denominator cut point, you say denominator cannot equal 0. So x plus 2 can't be 0. So x can't be negative 2. Denominator cut points are always open circles. Open circles mean you're not including those as answers. You wouldn't want to put a negative 2 in here for x, because you'd get a 19 on top and a 0 on the bottom. If you punch 19 divided by 0 into your calculator, it's going to give you an error. You can't divide by 0. Draw my two two number lines. Let me draw my number line. Put my 2 marks. In the homework we had some problems where there were a whole lot of cut points. I think one of them had 4 cut points. Here, I think all of these just have 2. Open. Let's see. I've got to label 11 over 4 and negative 2. The negative is certainly going to be to the left. And I will test an interval now. Let's see. I'm going to test 0. Where does 0 lie? Between 2 negatives, between 2 positives, or between a negative and a positive? Well, 0 is always between a negative and a positive.
You can't do it between the 2 positives at all?
Oh, well, if you're going to test here, you wouldn't be testing 0. You would have to choose 11 over 4 would be 2.75, so you could choose something like 3, 4, 5, 6, but 0 wouldn't be between 2.75 and larger. 3, 4, 5, 6, 7, 8, 9, 10, 20, a million. Okay? Just like 0 wouldn't be over here. What would it be? It'd be after negative 2, negative 3, negative 4, negative 5, and so forth. 0, if you're just testing 0, it's always going to be in the interval that has a negative on one side and a positive on the other. Testing the 0. I'm plugging it into the original problem. 0 plus 21 is 21. 0 plus 2 is 2. And it says it's less than 5. Oh, what the heck is 21 divided by 2? If you punch that into your calculator, you're going to get 10.5. 21 over 2 is 10 and a half. So 10 and a half, or 10.5, is less than 5. True or false? False. So we'll say false, true, and true. Okay. So parentheses, negative infinity, comma, negative 2 parentheses, union, parentheses 11 over 4 to infinity. But wait a minute, we're only wanting which one of them? The first one. Look and see, A, B, C, or D, which one is negative infinity to negative 2? I'm thinking it is answer choice C. C. Okay. Any questions there? This is where we'll take a break on this, and we'll finish it up at another time. This is Anthony Precella. Thanks for watching.